All right, welcome to Chapter 2 of IA 221. In Chapter 2 of the book, we're going to talk about the fundamentals of process control. Now, as I did mention in my introduction, process control is how we talk about what we need sensors for. So I don't like to just say, here's the thing, learn it. I like to say, here's the thing, here's why it's important, how it's used, now learn it. So this is why sensors are important, and this is how they are used. And so we learn about a couple different major kinds of process control, and we learn about some key terms in process control so that when you start diving into how we're using these sensors, you understand what the heck they're talking about. So process control, we all know what that is, but right here at the beginning of chapter 2, it gives you a very good definition. So um, process control is a system. It isn't a thing, it is a system of elements that combines measuring materials and controlling instruments into an arrangement capable of automatic action. So it's something you're measuring and something you're controlling together with some sort of automation. Does it have to be a computer? No, it doesn't have to be a computer. There's a variety of different control systems out there that use mechanical methods. Um, and we're going to talk about one of them. And one of them is found in your house, sitting behind you as you read articles in your abode, um, on your commode. So we're going to talk about how that works. So process control is a very important term. Now, how you control process, we instead of just saying the thing that you control and the thing that you measure and just using generic terms like that, we're going to learn some key terms, and I'm going to highlight them as we go here, because a variable is something that you can measure in terms of instrumentation and process control. The process variable, and this is very important because we often abbreviate that as PV. So if you see the words PV, you should automatically instantly know they're talking about the process variable. That's the independent variable that is to be controlled in a control system. That's the thing you're trying to control. So your process variable in say, your house, where your heating system is trying to control the temperature in your house, the process variable is temperature, right? We've also have pressure, level, and flow. Those are other process variables. So your process variable is the thing you're trying to control. Your heating system tries to heat up your house in cold weather. We're just going to stick to heating right now and not go to air conditioning because that gets confusing. But temperature is your process variable. That's the thing you're trying to affect as part of your process. The second important one is your control variable, which is often abbreviated as CV, which they didn't put here. So control variable, take a note, is called CV very often. They did good here by putting PV, but they didn't do good by putting CV next to control variable. It's sometimes called manipulated variable, but hardly anybody uses that. It's what you're using to affect your process variable. So for a heating system for your house, your control variable would be turning on or off your heating system. Right? And they give you a couple examples, but let's talk about the third term that's very important here. The set point. In your house, you've got a thermostat that you can adjust to determine what temperature you want to have in your house. That thermostat where you set your temperature, you are entering in the set point. So the set point is a third very important term, and that's almost always abbreviated as SP. So PV, CV, SP, they're very, very important terms. So the book then talks you through a couple examples of how to apply these different terms. So you can read through those examples. The book talks about automation in a couple different terms. It uses a couple terms that I don't think are critical. They're not common usage across many industries, but they're useful to read about because every once in a while you'll find somebody who says the word process automation. That's basically just talking about any automation that occurs in a process environment, usually batch, like batches of cookies or batches of potato chips, or continuous processes like manufacturing lines, like gas and oil systems that just continually produce fractionated gasoline products. Or they might talk about factory automation. So these are both interesting terms. Then the book dives again into control elements. And I once again highlighted the PV, CV, and SP. And interesting, here on page 13, they do give you that CV as the abbreviated form for control variable. Another term that's sometimes used is primary element. Primary element is your sensor that senses what you want in your process variable. So the primary element for a house thermostat is a temperature sensor built into that house thermostat. That temperature sensor is usually right there in the thermostat. Fancier home management systems have multiple sensors in multiple rooms, but the generic one for most people is built right into your thermostat. We also use the term final element sometimes, but not that often, to describe what you're using to control the process, and that might be for your temperature control system in your house. That's simply an on-off switch that controls the gas into your furnace. And it's usually more complicated than a simple switch. It's a whole turn on the furnace process that most automated furnaces have. So the few other key terms in here. This up here, and we're going to get into this in the next chapter, is an example of a special kind of diagram. We talked about wiring diagrams before. We talked about pneumatic and hydraulic diagrams in fluid power class. This is a fourth kind of diagram. It's called a P&ID, and we're going to learn about P&IDs in chapter 3. There's a few other key terms that we're going to revisit over and over. I'm not going to dive into describing exactly how these work in this class, but these are key terms that we're going to find useful in individual sensors, specifically in how we determine which sensor we're going to use and how that sensor can function. And we're going to dive into these in other classes, but you need to know what the range of the sensor is. You need to know its span, which is different than the range. You need to know what a bias is. I'll give you a hint. Bias is just how wrong that sensor is from an absolute measurement. Accuracy versus precision. These are two different measures. In the English language, we often confuse these two terms, but as a technician for sensors, you need to know that they mean different things. So I want you to read through this, come up with some questions, and then in the lab, we're going to dive in and show examples of this. Other key terms are highlighted here: repeatability, sensitivity, drift, reproducibility, I'm sorry, I can't even speak, response time, hysteresis. Hysteresis is very important. Let me put a big arrow next to that. It's one of the key factors in many different control systems. Hysteresis is essentially the dead zone in response to a given system. Stability, very important. The next section in chapter 17 talks about control loops. So let me just stop for a second.